Well, hello, welcome. We're just going to have a little conversation here with JI. I'm Joe. I'll just introduce myself first. So I'm Joe Niemela. I'm actually from ICTP. Hi, Louis. ICTP is the International Center for Theoretical Physics. It's actually the Abdus Salam ICTP, named after our founding director. And so we're a UNESCO center, and so we actually are fostering research around the world, and I can talk a little bit more about what we do later. But also I led the effort through the United Nations to get the Year of Quantum Science and Technology proclaimed by the United Nations. So we're going to have a little conversation about that. Now, J.I., you can.
So thank you, Joe. We had so much fun before joining here the stage, okay? Well, at least I had fun. So we decided that we don't have surnames, we only have Joe and J.I. I should introduce myself. I'm J.I., the chief researcher for the Quantum Research Center at TII here in Abu Dhabi. We're defining the future here. So before defining the future, we are celebrating the year of quantum next year, as the UNESCO has decided that. So, Joe, you are in charge of that. How do you make a year of quantum?
Yeah, well, yeah, ironically, I actually work in turbulence, so I'm one of the few people that doesn't actually work in quantum, although I have worked in quantum fluids. So at any rate, so that's an interesting question. So I'd like to, I see we have 20 minutes. Okay, so I'd like to go back a little bit to the beginning, because we were planning on, there's been a lot of discussion amongst the physics community and the chemistry community around the world, noting that we're approaching the centennial of the birth of quantum mechanics. So this is Heisenberg and Schrodinger's efforts to mathematically treat quantum science. And this allowed it to be calculable and led to all the wonderful advances we see now and are looking forward to. And I think, J.I., you're going to talk a little bit about that background. But with that in mind, actually we got so I talked with so these were conversations. There's lots of conversations actually, but one particular conversation was between the American Physical Society and the German Physical Society. And so the idea was to discuss this centenary, the quantum century, as they were calling it. But I got a call from the CEO of APS, the American Physical Society. He said, you know, we're thinking about an international year, but what is that? How do you make it happen, and what do you do? And so we had a brief chat for about an hour and a half, and then at the end he said, okay, why don't you pick your team and go? So at any rate, we started. So the idea is, the first thing to keep in mind is that when you have an international year proclaimed by the United Nations, you can't do it yourself. So there's actually no call for a proposal for an international year. There's nothing you can do as an individual scientist by yourself to have that happen. You have to go through member states, et cetera. So at any rate, and international years are proclaimed by the United Nations in New York, but they generally fall under the purview of UNESCO, which is the United Nations Educational, Scientific, and Cultural Organization. And so we started at UNESCO just to make sure they were on board. And the first thing we had to do, I'm taking the long way around. First thing we had to do is actually make sure this was a global event. We had societies and academies of science from around the world, from every continent, involved in endorsing it and partnering with us on this. So it wasn't a U.S.-centric or European-centric event. It was really a global event. And that's the difference between what could have been like Laserfest, for instance, in 2010, which is just a celebration among societies. But we really wanted to open this up and try to promote really physics or science for humanity. And that's so following what the United Nations would like to see. And so, but you need a member state to do this, to lead the way. So anyway, we formed a team. So I chaired this, what's called the Executive Committee for the International Year of Quantum Science and Technology, and that's why you see my title. And the Executive Committee consisted of Paul Kazemansky, who was a historian and a quantum physicist himself, John Dudley, who's a photonics expert and quantum expert, of course, and Ana Maria Cheto, who was from UNAM in Mexico, who works in the foundations of quantum mechanics, but also was a former deputy director general of the International Atomic Energy Agency in Vienna. And so she was actually part diplomat, part scientist, and so that was very useful. So it basically evolved that Ana Maria and I spent a long time going to UNESCO. You had to get UNESCO on board, so you had to get all these organizations and show them that it wasn't just you had the backing of the international community. And the way you really showed that was to get the endorsement of the one physics organization, which is truly international. That's the International Union of Pure and Applied Physics. So that was in 2021. So that we go back, that's how long it's been. We really got this thing kicked off in the fall of 2021 with the endorsement of IUPAP. And from there, we went to UNESCO and said, okay, now we have this backing. Are you gonna, will you follow us and allow us to do this? And of course, UNESCO can't do anything, the Secretariat, because remember, it's the Director General and everybody else that works at any UN organization is just part of a Secretariat that's trying to implement things, plans that the member states have in mind. So anyway, but we got their blessing, but we had to go do our work, and then the work is to find the member state. The member state was Mexico, and so we started working with Mexico, and it really involved a number of things, but we had to actually do the work. So you can't just ask a member state to lead the effort, and then you say, well, we'll come back later, let us know how it worked out. You really have to, it's really a partnership, and it's a partnership with typically people you don't usually talk to, and these are people from the foreign ministries, not the research ministries. And so, in a sense, we had to write the resolutions, the briefing documents, et cetera. So anyway, that was a long process. We went through the executive board, went to the general conference, and finally got that go-ahead. And so the general conference only recommended the United Nations proclaim the year. Unfortunately, there's a lot of hot wars going on, and we had a hard time finding another country to do that. So in the end, Ghana came, so now Ghana took it at the UN. We went there, we talked to people, and I think in April, we had a meeting. Ana Maria and myself went there and talked to member states. And finally, it got on the agenda of the General Assembly, and June 7th, it was proclaimed by the United Nations. That's where we started, just this last June, so we're 5 months into it, and since then we've been scrambling to really catch up because we're a little bit late. So anyway, that's where we are, and that's how it goes.
So thank you, Joe. I would like just to remind the people why we are celebrating century. So I don't know if you ever thought, when was the first equation of quantum written, quantum mechanics? So it happens that we know exactly, and this happened October 7th, 1900, okay? And it was Planck who tried to describe the relation of one experiment, the two regimes, and they finally he found an equation that was very fortunate. He said it like that in a postcard he sent to his colleagues in Berlin. After 1900, it took a lot of time to understand what was being discovered. So there was 1905, Einstein, with a lot of contributions. Then there was 1913, we have Bohr with the atom trying to describe. Then there were struggles to understand what was the meaning of that. But it was in 25 when finally we had Schrödinger writing the equation that carries his name, and Heisenberg understanding the uncertainty principle and other ideas in a little island in Denmark. So since then, just in one go, we have, in the 40s, we understood semiconductors, physics. We create our transistors, your computer, your phones, carry quantum mechanics. We discover the coherence of light in the 60s, all the lasers, all our communications, and like that. In the 40s, we understood what we call two-level systems. Those are the magnetic resonances that you get in your hospitals. It turns out that our modern economy, more than 50% of the economy is based on our understanding of quantum mechanics, so it is really worth celebrating what we are celebrating. So Joe, what are the actions you think will be most relevant in the planet?
Yeah, so, well, you have to actually understand what the member states really wanted to see. And they wanted to see a number of things. One was global cooperation in science, because that's always relevant, and that's been relevant for a long time now. They wanted to actually raise awareness, not just with scientists. So we didn't want to just slap ourselves on the back and say, good job, because we can do that anyway. But it was really bringing awareness of what quantum science and technology can do for humanity to raise the level of our existence, to improve our quality of life. And that was really the main goal. But that involves a lot of things. So anyway, so global cooperation, raising awareness, education, getting this. The other thing was quantum science and technology is everywhere. It actually is exciting to young people. And so, you know, the other thing is just to try to motivate young people to go into science and use this as an excuse to get it into schools, because if the UN is endorsing it, it's proclaimed by the UN, that gives teachers the opportunity to take this into the classroom and get the permission to do so. So anyway, that was another thing. And then just because quantum science and technology is an economic driver, I think we want to try to promote that aspect of it as well. And so anyway, so we're going to kick it off with a opening ceremony on the 4th of February. And this will bring Nobel Laureates and great scientists from around the world to Paris, to UNESCO headquarters in Paris. We'll talk about the science, but we'll also talk about the ethics. So ethics is very important. One of the things is actually also we're seeing an erosion of trust in science. I don't mean trust in science, I mean trust in the science. Well, actually people do not trust the science, and you saw that with the vaccines in the pandemic era, but really it's somehow we have to get this message across about the trust in the scientific method, because that's really what you say when you say trust in science. You mean how science is done, how it self-corrects. And so that's a very important component. It's important that we talk to everybody, not just we talk to policymakers, but we also talk to school children, we talk to the general public, because we have a lot of societal challenges. We all know those. There's climate change coming, there's energy, there's food security, the access to clean water. There are a lot of, depending on where you are in the world, but pretty much it's coming for all of us. And so these are societal challenges, and it's not just the technical solutions. You need to have the society accept it. So we really need to have this conversation with everybody in society, and so part of what the International Year does is really you talk to everybody, talk to people you don't usually talk to. And we started with that with the diplomats, but really we all have to do that. So anyway, we have lots of programs. It's not going to be centrally located. Run. We do have the opening ceremony, we'll have a closing ceremony, we'll have various actions, large activities in each continent, well, almost each continent. But besides that, it's mostly grassroots. And the idea is to give ownership of the year to everybody, all the scientists, all the people around the world, including artists, including educators, philosophers, whoever wants to take this. We really would like to see this owned by everybody, and that's the only way it really becomes a global activity. And you have to actually act locally, think globally, act locally, and that's sort of the way we're looking at it. So anyway.
So Joe, let me phrase the concern. Let me move to something which is less comfortable. Okay. Many people think that advanced science, and let me frame artificial intelligence and quantum mechanics, quantum computing, quantum communications, is a property of the advanced countries. So actually that all the efforts that we are doing will increase the gap between nations. that a number of nations will be left behind, lagging behind. And many people, and I'm one of them, believe this is not good. I don't believe that the countries should be unequal, okay, in knowledge. We are talking about knowledge. It's not only technology. Technology is the result of having knowledge. If you have knowledge, you can create technology. So the fact that knowledge is being generated in only a few places in the planet is of concern for many people, and I'm one of them. So I do believe that we have to pay special attention, not to the word ethics, but to the reality of ethics, the reality of having a lot of consensus that it's humanity which is reaching the next level in understanding of quantum mechanics. We are understanding how to control individual atoms, individual elements of nature. We can do amazing new things with that. It is super important that that knowledge is shared by everybody. So you, Joe, have been an instrumental person in the center in Trieste called ICTP in Italy. So you have been voicing the need of having knowledge distributed in the planet, no? Is there any special action? Is there anything new during the year of quantum in this direction? Or we will see the opposite? We will see that the rich countries will be wiser in knowledge of quantum and other countries will no longer be there.
Yeah, well, that's a really great point, because what I didn't say was member states really, this idea of equitable advancement. So it's not equal advancement, it's just equitable advancement. We really do need to involve the whole planet. It can't be another situation where everything gets evolved in the West and the North, and then it trickles down much later to other countries. I mean, we really want to involve a lot of people. And I think one of the things that Bill Phillips had said recently was that, you know, thinking about the quantum 2.0 and what's coming up, there's a lot of startups, and you see a lot of startup companies in this particular event. And these are operating on budgets which actually are accessible to developing countries. And I think, so in this sense also, you know, there are opportunities. But at ICDP, so in case you didn't know, so ICDP is a kind of a special place, not just because I'm there, but it's, no, but it was really started 60 years ago. We just celebrated our 60th anniversary a couple of days ago, actually. And so it's really, the whole idea was to foster research and development, to end the isolation of scientists from around the world. And so this was the problem that Abdus Salam, who was a Nobel laureate, faced himself. He came from Pakistan. He did his education in the UK. He went back to Pakistan, and then he found out that really there was nobody to talk to in his area. I mean, he felt alone. And you can imagine in those days, this is back in the 50s, so he couldn't really, you know, there was no internet. It was very difficult to communicate, and it was very expensive to travel. It took a long time anyway. So anyway, ending isolation of scientists was one of the original ideas, the motivations for having a center, where it wasn't a center to take scientists out of the developing countries, and really that's our focus. It's the focus of the entire United Nations now, by the way. It wasn't the intention to bring them out, it's the intention to bring them to ICDP to mingle not with themselves, but with everybody, also from the industrialized countries. So that was the idea, to be there at the forefront, because if you're not at the forefront of science, at that moving edge, you're just not you're not able to have that career. So it's a question of, do you have a career in science? Are you going to help develop the science? You really need to have access to publications, to know what's being done, to be able to talk to people in your area doing those things, et cetera. Just like it was just so easy in Europe and the United States, in North America, but it's not so easy in other countries. So that was our motivation, and certainly we're going to do during the year of quantum. We do what we always do. I mean, we bring about 5,000 people, scientists, a year. We've had 160,000 scientific visits in our history. And so I think we're going to, obviously, we just continue doing this as we've done before, and try to help scientists maintain a career and not necessarily have to leave their country as Abdus Salam did.
Thank you. You know, I recommend people to visit ICTP. It's really a remarkable place, remarkable. But I would like Joe to tell you a little bit what we are doing here in Abu Dhabi. As you know, 4 years ago, the Quantum Research Center was created. We are over 100 people now, and we carry 6 lines of research. But there are some principles that we follow in this direction. So let me give you an example. We have created the software to control a quantum computer. We call it Kibo, and we made it open source immediately. We were the first people to make open source the middleware of quantum computers, and we will remain so. And not only that, but our strategy is the one of welcoming really everybody, all nations. We want to really work together with people that have no access to this technology. And our quantum computers, which are starting to work now, I got results of 2 days ago, and we are there, we are getting there. We already have quantum devices that work according to the laws of quantum mechanics, and they compute, and we want to open that. We want to open that to really universally as much as we can. So I do think that there are many, many companies that use the words that we are equality and all that, and very few that do. We will be makers. We will be those that do act, okay? So I believe in action, not in words. And this, believe me, you have to come back here every year and you will see. This will be, the future ICTP will be here.
I have no doubt. And besides, so I understood that you were working on the turbulence problem because that's my area. And you know, doing computational fluid dynamics takes a big computer. And actually, I consider all computers to be quantum computers. So I guess qubit would be a better. I have to figure out the right way to think about that. But at any rate, so I understand you're actually going to.
Yeah, we will
delve into that because that's a difficult problem. You know, engineers know how to control turbulence. I mean, turbulence is the usual turbulence they worry about is the turbulence over an aircraft wing or something like that. But you know, they can control it fine. But the understanding is another matter. And I think as physicists, we'd really like to understand it, and so we really need to be able to compute it and precisely.
Yeah, I know. Well, I was told by a very good scientist many, many years ago that turbulence was the most difficult problem in human knowledge. Well, I don't know if I agree with that, but anyway, there are other problems which are pretty complicated. But we are all the time talking sort of politics, all of things, and if anything, why I'm here is not because of that, no? It's what it means to be a physicist or a scientist or somebody who decides that his life has to be devoted to knowledge, not necessarily to other things. So I would like to ask you this personal question. No? Okay. What is your life? I mean, what has been science for you? Why are you a scientist? You are in the position that you are now handling the year of quantum for the new generation. So why are you a physicist?
Yeah, well, you might ask, why are you leading it? No, well, actually, you know, the funny thing is, I didn't start out, I take that back. I wanted to be a marine biologist because I really love Doc Ricketts. And does anybody read Cannery Row? Anybody know John Steinbeck? Nobel Laureate? You do, okay. Well, Doc Ricketts is actually a real marine biologist. I read his textbook when I was 11. I really wanted to be one. But then I kind of gave it up. Then I moved to the humanities. I'm a musician. I play saxophone, mostly. And so I did a lot of things. I love theater. And I thought I was going to move that direction, but then, I don't know. But I love science, too, so I loved everything. I think, you know what it was? It was Aldous Huxley. Anybody know Aldous Huxley? The author, Brave New World, a visionary. We're talking about visionaries here, so he was one of the most visionary authors around. At any rate, he kind of convinced me that this is something, and it was really fascinating. So I just worked my way back into the physics. So I've actually had a lot of fun. I'm an experimentalist, so I'm working at by the way, that's another contradiction. I'm working at the International Center for Theoretical Physics, but I'm the only experimental physicist there. but it doesn't really matter. In fact, Abdus Salam actually regretted it a little bit later. I mean, the idea of theoretical was really because that was deemed to be a little bit more economical than doing experiments. But it's not really true. Yeah. So, at any rate, I think, I think it's just all these things that are curiosity-driven. I mean, just that it's been fun. I enjoy it. I think that's the reason I stayed in it, because I actually enjoy it, and I just love tinkering. So, and finding, when you find something out, it's wonderful. And, if everybody had that, yeah. At any rate.
Let me tell you my story.
Yeah, you have a better story.
No, not my life, but only one anecdote. One of the classes when I teach quantum mechanics that I love the most is when you explain what is called the Dirac equation. I think if you think of what is beauty in science, that is the Dirac equation. And I always said the same thing when I finished my class. I used to say, you guys, to the students, you guys, we are from Barcelona. We play soccer in Barcelona. We are very good at soccer. You all love Barça. But you know what? You will forget the results of Barça this year. Not this Sunday, but this year. You will forget all these things. You will never, never in your life forget the Dirac equation because it's imprinted in your brain. It's beauty at the core of your brain. No? And I think they remember. No, eventually I meet them and say, you guy, I remember what you did.
Yeah, in fact, I had a philosophy professor who actually had a PhD in mathematics, and we had a class in aesthetics, and he would talk about the Dirac equation as a thing of beauty, right?
Apparently, Google's asked, what is the most beautiful equation? And if you said E equals MC squared was bad.
Oh, no,
if you said exponential PI was bad. If you said Dirac equation, you were in Google. You passed the test. Anyway, Joe, we are finishing. Could we have a final idea, some final thought?
Well, okay. So one thing is that this is a community event. I mean, it's a whole global community. We would like to go back to the United Nations at the end of the year. We would just like to have involvement from everybody. And then we will have there is a website, and we would love to have people register. Whatever you do for the year, whatever plans you have, just think about them. Put it under the International Year of Quantum, and we'll take that back to the United Nations and show them what the community can do. The other thing I'd just like to say is that, we're talking about the future of quantum, but there's also the present. And there's a lot of these technologies, something as simple as the light-emitting diode. I mean, the invention of the blue LED, which got a Nobel Prize in 2014. I mean, this really has a strong impact. And when you go to developing countries, villages off the grid, just to have a lighting source that's not kerosene is has a tremendous effect. Having point-of-care devices and lab on a chip and all the spectroscopy you can use for food science, for lighting, for agriculture, remote sensing. So there's a lot of, just with existing quantum technology, there's a lot of things that are improving the lives of people all over the world, and we'd like them to actually share in this knowledge creation as well. All around the world. So that would be my thought. We really want to, I'm going to go back to what you said, we really want to make this equitable advancement, equitable knowledge creation in the year, and maybe that would be one of the nice things that we come out with as an outcome.
Thank you. So on my final comment is that please stay tuned, because there will be so much going in Abu Dhabi and in UAE in the next year, starting with a fantastic conference of science in January, and a number of announcements you will see coming little by little. It was presented by the leadership of the country on the first day that quantum is a focus of UAE. UAE will be relevant in the world of the new technologies, so please stay tuned. I would like to finish. You know that every time we finish here, people applaud, and then there is a voice saying, please join me. So I talked to that girl and I said, let me do it. So please join me in a round of applause for Joe. Thank you very much.
And gratitude. And for JI. It's a JI and Joe show.